let's do a little bit of review. So this is from 6.5 and 6.6. Remember, we talked about graphing tangents, so I can give you something like graph y equals 2 tangent of pi over 3x plus 1/2 all up to 2 plus 5. So here's a perfectly good tangent function to try and graph. How do we handle this? What's the strategy? Remember? So A, B, and C still apply here. What's A, B, and C? A is 2. B is pi over 3. And then C is negative pi over 2. For C, you change the sign always. And then when we graph tangent, we want to find the period and the quarter period, and then also where it shifts, right, where the 0 moves. So we have to calculate the period first. How do we do that? Whoa, is it 2 pi over b or pi over b?
Pi over b.
For tangent, it's pi over b. Right, so in this case, that'll be pi divided by pi over 3. So when you flip and multiply, you get pi times 3 over pi. The pi's cancel and you just end up with 3. So the period for this function is 3. And then the quarter period just comes from dividing that into quarters. So you'll do 3. The quarter period is always the period over 4. So 3/4 is the quarter period. The other thing we talked about was like the phase shift. Okay, it's the same idea as the phase shift, and it's kind of where your 0 moves. Normally, tangent has a 0 right on the origin, but if you start adding a bunch of extra numbers in here, the 0 moves. So where does the 0 move? How do you calculate it? C over b. So in this case, that's equal to negative pi over 2 divided by pi over 3. Flip and multiply. Negative pi over 2 times 3 over pi. Pi's cancel and you end up with negative 3. Now, because my quarter period and my new 0 don't have the same denominator, I'm going to make a simplifying calculation here. Right, this guy's got denominator 4, and I'm going to have to end up adding him to this guy, which has denominator 2. So let me go ahead and write this with denominator 4. How would I do that? Yeah, get your common denominator by multiplying top and bottom by 2. So this is just to make our calculations easier as we go. Times 2 times 2. So this will, oh, that wasn't 4. That was 2. Check that out. So we got negative 3/2 originally, and then I multiply by 2 over 2 to get negative 6/4. So this value is where our new 0 is. This is kind of going to be like the center of my tangent graph. And then this is how I'm going to count to the left and right. This is how many units I'm going to move to the left and right. Remember, tangent kind of unfolds from the middle. You don't graph it quite the same as sine and cosine, right? With sine and cosine, you start and then always go to the right when you're graphing. Tangent, it's a little bit easier to start at this 0 and go left and right. So I'll put negative 6/4 over here. So at negative 6/4 I have a 0. That means I actually hit the axis. Then if I move right 3/4, what's going to happen? Not asking.
No.
You go to A. whatever A is. Right? You have to go 2 quarter periods for now. Right? The structure of tangent, if you remember the original tangent graph, the way the original tangent graph broke down is it had asymptotes at pi over 2 and negative pi over 2. But the quarter period was actually pi over 4. Right? So this is the original tangent graph. So on the original, when you go over pi over 4, one of the quarter periods, you get out the A value, which in this case was 1. So in this new tangent graph, when I go over a single quarter period to negative 3 pi over 4, not pi, just negative 3 over 4. When I go over a single quarter period, I'm going to go up to the A value, which is 2. This is almost like an amplitude. You go up 2. Then when I go another quarter period, when I go my second quarter period, another 3/4, then I get an asymptote. So the structure for tangent is the same always. When you go 1 quarter period, you get the A value. When you go 2 quarter periods, you get an asymptote. And then I do the same thing in the other direction. 1 quarter period left, what's that going to put me at? You subtract 3/4 from negative 6/4 and you get negative 9/4. 1 quarter period left, what's my Y value? Negative 2. Now we go down instead of up, right? We go the opposite of A. And then when I go 2 quarter periods left, negative 12/4, or negative 3, I'm going to get out another asymptote. And then I have enough information to sketch a pretty good graph. Something like so this is 2 tan pi over 3x plus pi over 2. What do you think? It's all right? For now, until you try it. Until I quiz you on it, and then it'll all be gone magically. So, this was the first part of 6.5 and 6.6. But then also we talked about graphing reciprocal functions, so secant, cosecant, cosecant. To graph reciprocal functions, you have to use these nice facts. Okay, for reciprocal functions, talked about this at the end last time. There's 3 important facts that help you change a regular function into a reciprocal function. So that help you change sine into cosecant, or cosine into secant. And basically what it comes down to is that zeros exchange with vertical asymptotes. So if you have zeros on one function, you'll have vertical asymptotes on the reciprocal. Maxes become mins. And any kind of 1 stays the same. So, we talked about this a little bit last time. Let me just give you one refresher of what I mean here, and then we'll move on to these examples. So for example, if I wanted to take sine x and change to the reciprocal function, which is cosecant, first I would graph sine x. Sine x looks like up, down, is 1 period of sine x. Let me go ahead and put on my x values. I know that everything happens at quarter periods. So for sine x, the period is 2 pi, half of that is pi, quarter of the period is pi over 2, and this guy would be 3 pi over 2. And what does sine x bounce between? What are the y values? 1. For regular sine x, it's just 1 and negative. So to translate this to the reciprocal function, I have to focus on zeros, maxes, and 1s, or zeros, mins, maxes, and 1s. So for example, these are zeros, because my function equals 0 there. So on my reciprocal function, what's going to happen? Those turn to vertical asymptotes. So at 0 and pi and 2 pi, I have vertical asymptotes. Then let me focus on maxes and mins. Here I have a max at pi over 2, 1, and here I have a min at 3 pi over 2, negative 1. So the max is going to turn into a minimum, which means at pi over 2, comma 1, instead of going downward to give me a max, I have to arc upward like this. And this 1, this value of y equals 1, stayed the same. Same thing at 3 pi over 2. I have a min, so that's going to change to a max. So instead of arcing upward, I have to arc downward. So like this. But the value, the y value of negative 1 stays the same. So this is cosine, because that's the reciprocal. 1 period of cosine. And then we did secant and we did cotangent last time. But I just wanted to remind you kind of how these 3 facts come into play. So far? Why not? Okay. One thing that you will probably start doing, and I suppose I encourage, you don't really need 2 separate graphs here. Okay, you do need the graph of sine, otherwise getting to the graph of cosecant is kind of difficult. But if you want to, you can combine these into one. So you can simply, I would do something like graph sine of x with a dotted line or something to distinguish the two, to be very nice to me. So I know you know what you're talking about. Right, so I could graph sine of x maybe like this. And then on that very same graph, I could graph cosecant by, well, first putting a vertical asymptote everywhere I have a 0. And then taking this max and turning it upward, so it becomes min. And then taking this min and turning it downward, so it becomes. So if you wanted to do that, to save yourself some paper and some time, that's perfectly good with me. Oh, we should probably label these y values. So let's do our examples. So the last 2 examples, let's see, I gave you a secant and I think a cotangent. So those are both reciprocal functions. Let's try and graph those both ones. Graph 2 periods of the function y equals negative 3 secant of 2x. We're talking about y equals negative 3 secant of 2x. So what is secant related to? What's secant the reciprocal of? Cosine. So I'm going to start by graphing cosines. All right, so let me graph first. Do it in purple. Let's graph y equals -3 cos 2x. And then once we have that, it'll be a quick trip to get to secant. What do I need to graph this though? ABC. Right? It's as easy as ABC. So A is -3, B is 2. What's C in this case? 0, right? Because there's nothing being added. That's nice. So then I say, all right, well, my amplitude is 3, technically. My period, what's my period in this case? Pi. Right? You do the same calculation as we were doing last section. You take 2 pi and divide it by b. Or 2 pi over 2. What else do I care about when I graph cosine? Quarter period, definitely. So quarter period will be pi divided by 4, right? You just take your period and divide it by 4. And then usually I would calculate a phase shift, but because C is 0, my phase shift is 0. So now I can use all this to get a decent graph of cosine. So I'm going to start from 0, since my phase shift is 0. And then I'm going to go pi over 4 to the right, since that's my quarter period. So I need to mark pi over 4, 2 pi over 4, 3 pi over 4, pi. My 4 pi. And then the amplitude gives me how far I go on my y-axis. 1, 2, 3. 1, 2, 3. Now because it's cosine, and because the a is negative, how am I going to start this? At -3 at the minimum. Start here at a minimum. Then I'll go to a 0, then to a max, and back down to a 0, and then to a min. So this is my cosine. What I would suggest with cosine, to get a nice picture of secant, is to go back a single quarter period. Because it would be very nice to start from an asymptote. Right? So if you can go back to a 0, then you can start your secant graph from an asymptote. It just makes the picture look better in the end. So if I go back a quarter period here, what will I be at? -pi over 4. And then the pattern of cosine will be it'll go from this minimum up to a 0. As you can see, I sort of ran out of room. 1, 2, 3. 1, 2, 3. -pi over 4. Pi over 4. So if you can fit it on the same graph, go ahead. But let me do another one. So here's secant, which is what we actually wanted to get to. All right, this guy was cosine. Secant is going to flip. All the zeros turn into asymptotes. So at -pi over 4, since I have a 0, this is going to turn into an asymptote on my secant graph. At +pi over 4, since I have a 0, that's going to turn into an asymptote. And at +3 pi over 4, then all the mins turn to maxes, and all the maxes turn to mins. So down here, since this was at -3, I'm going to have a minimum at -3. Oh, I'm sorry, maximum at -3, it wasn't one. And then over here, since my max was 3, I'm going to have minute 3. So I go to 3, and I go up. This is one period of -3 secant. Ask for 2. So I'll probably graph another one for you. But that's about how I got it. To graph another period of this function, should I graph another period of cosine? You could. You don't have to. Right, once you have one period, you can just repeat the same pattern. So if I ask for 2 periods, annoying, then you would just keep going with your quarter periods. There's 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And then I would just repeat the same pattern. You have, after this asymptote, you're going to have another, after 2 quarter periods, you have another asymptote. So you're going to get this. Right? Every 2 quarter periods, you get an asymptote. And then you're down at -3 right here, so you're going to be down at -3 after this asymptote. And you're up at 3 here, so you're going to be up at 3 over here. So there's 2 periods. Oh, it's kind of ugly. That's freaking me out. I don't like it. A little better. Give me some plastic surgery. All right. What do you think? You accept? You approve? Okay, good, good. I desperately need your approval. All right, let's try cotangent. Graph 2 periods of y equals cotan pi over 2x plus pi over 4. Cotangent of pi over 2x plus pi. So the strategy I've chosen to graph cotangent is to start with the reciprocal and then change all my asymptotes to zeros and yada yada yada. So let's start with the reciprocal function. How do we graph this? ABC. So A is 1, right? Because there's nothing in front, so you imagine a 1 there. B is pi over 2. And C is negative pi over 4. And for tangent, what's super important is the period and your new 0, right? Where your 0 moves. Oh, an important period. So the period. Formula is always pi divided by b for tangent. So in this case, we'll get pi divided by pi over 2. When you flip and multiply, this becomes pi times 2 over pi, or just 2. So then the quarter period is 2 over 4, or 1. What about our 0? Where's the center of our tangent graph going to be at? How do we calculate it? C over b. So negative pi over 4 divided by b pi over 2. Flip and multiply. Pi's cancel. sound that pi's make when they cancel. Negative 2 over 4, or negative 1. Now I think I can get a decent tangent graph. My 0 is going to be at negative 1/2, so I'll stick negative 1/2 right here. And then everything important happens quarter periods for negative 1/2. So I'm going to go 2 quarter periods to the right and 2 quarter periods to the left. I'll go 1 quarter period, 2 quarter periods, 1 quarter period, 2 quarter periods. And let's actually put down what happens here. This is my 0. So I'm going to put a 0 right here. Then if I go 1 quarter period to the right, what's going to happen to my tangent graph? It's going to be at A, whatever A is. Just 1. So I'll put 1. And if I go 2 quarter periods to the right, what happens? Asymptote. Trouble. Right? 1 quarter period you get A, 2 quarter periods asymptote. 1 quarter period to the left, you get out negative A, or negative 1 in this case. 2 quarter periods to the left, you get out asymptote. So that's it, we're done, circle it. Take that problem off. No, this is not what I want. I want eventually cotangent. This is tangent. So what I'm going to need to do, I'm actually going to need another period. You're always going to want 2 periods of tangent to get a pretty cotangent graph. But that's all right, you guys are masters at graphing second periods, right? How do you do it? Just copy it, right? Copy and paste, right? Control C. So go to your quarter periods. 1, 3/2, 2, 5/2. 1, 2, 3, 4 quarter periods. You get an asymptote at the end of that. You get a 0 right in the middle. When you go 1 quarter period from a 0, you get 1, right, A. When you go 1 quarter period the other way, you get negative A. So this guy we can turn into cotangent. I would not graph cotangent on top of tangent only because it's going to be so filled with different lines that you're not going to have any idea what you drew. But if you make it clear enough, I guess I can. So I'm going to go ahead and make a new graph, right? I'm going to put negative 1, I'm going to put all my x values. Because none of the x values change. Now going to the reciprocal function, zeros turn into asymptotes. So this guy here and this guy here are the only zeros of tangent that I have graphed. So those are going to turn into asymptotes here, right, at negative 1/2, and here. What about at this asymptote? What's going to happen on cotangent? 0. And then what about this 1 and this negative 1. These points stay the same. So if you have 1 on the tangent graph when x equals 0, you're going to have 1 on the cotangent graph when x equals 0. And if you have negative 1 on the tangent graph when x is 1, you're going to have negative 1 on the cotangent graph. So what does this look like? Another snake. It approaches the asymptote and goes through these points. That's one period. You could graph another one. Just repeat the same pattern. Cotangents are a little more tedious to graph this way. If you want, you're more than welcome to read the book. They probably have a different method for graphing cotangent. I like this method because it's the same for all the reciprocal functions. Secant, cosecant, cotangent, the same thing. Graph the first function, change zeros and asymptotes, keep 1 to the same. Because it's pretty. Look, if I only have one period of tangent, I only have 1, 0, right? And that means I only have 1 asymptote. Right? But if I have 2 periods of tangent, then I have 2 zeros, which will give me 2 asymptotes. And graphs, these reciprocal functions just look prettier if you have 2 asymptotes on it. Right? If you only graph 1 period of tangent and tried to do it from there, you would get something funky like this. It would be correct. I mean, what you would get would be fine. You'd have 1/2 here, but you just have like 1 asymptote, and then this half of your snake on this side, and then this half of your snake on the other side. Like it just doesn't give you the full picture. This makes it look pretty. More superficial. We're extremely concerned with things that look pretty. Yes? So in the original guy, when I graphed tangent, the sort of the procedure, the structure, the way tangent works, you start from a 0, and then every quarter period, if you go 1 quarter period, you get out A. But if you go 2 quarter periods, you get out an asymptote. Always for tangent.
So every quarter period from 0, every 2 quarter periods
Yes.
from 0.
You have an asymptote. How would you, this last remark here, how would you graph the same exact function, cotangent of pi over 2x plus pi over 4, but with a -2 on it? Alright, so just to make sure you remember how this works, if I gave you y equals cotan pi over 2x plus pi over 4, but then I stuck a -2 on the end, what does that do? Vertical shift. Down, down 2. So to graph this, you would have to draw the exact same graph, except all of your y values would move down 2. Same as before.